Hey guys. So last week we did the terrestrial planets. So we covered Mercury, Venus, and Mars. We talked about Earth weeks ago. This week we're going to basically finish up the solar system. We're going to cover the gas and ice giants. So Jupiter, Saturn, Uranus, and Neptune. And I'm going to go ahead and sneak Pluto in there. We would have had a presenter doing Pluto. We have a lot to say about Pluto, and we still feel a special way about Pluto, even though it's not technically a planet anymore. So Pluto is going to be put in this presentation. You are going to get a little something about Pluto. Let's go ahead and get started. So going from the asteroid belt out, the first gas giant that we run into, hopefully you guys all know, is Jupiter. But before we get there, let's do a quick overview of all the Jovian planets. So Jovian, it just means Jupiter-like. So all these fall under the Jovian category. We have Jupiter, Saturn, Uranus, and Neptune. All of them are much larger than the terrestrial planets. They range from 4 to 11 times the diameter of the Earth. And all of them have way more moons than the terrestrial planets. The terrestrial planets at most have 2 moons, and that would be Mars. Mars has 2, Earth has 1, Venus and Mercury both have 0. All of them have rings. This is one of the big misconceptions people have about the solar system. Everyone knows Saturn has rings. Some people know Uranus have rings. A lot of people don't think Neptune has rings, and I don't think anyone thinks Jupiter has rings, unless they're into space. All of them are mostly composed of hydrogen and helium, so this is where they get the moniker gas giants from. And all of them, since they're mostly gas, experience differential rotation, which is where different chunks of that gas is rotating at different speeds. Like with the sun, we talked about this previously. Pluto, on the other hand, is not a Jovian planet. Pluto is the largest dwarf planet in the solar system. It is smaller than every true planet, even Mercury. It does have 5 moons, though, so good job, Pluto. It has no rings, and it's mostly rock and ice. Moving on to Jupiter. So here is a nice photo of Jupiter here. This is from Hubble. You can see the credits down at the bottom there. It is the 5th planet from the sun. It goes Mercury, Venus, Earth, Mars, asteroid belt, Jupiter. It is the largest planet in the solar system, though. 2.5 times more mass than all the other planets put together. And its surface, so what you're seeing here on Jupiter, is actually just clouds. And each of these little bands, so you see like there's different layers to Jupiter. Here is this nice straight white line, and then you have this swirling brown red band. All these are different bands of clouds and just gas that are swirling in one direction and some going the other direction. The fact that they're going in different directions like that is what's causing this guy right here. That picture, that's the Great Red Spot, which is definitely the most famous feature of Jupiter. Jupiter's name, it's Roman for Zeus. So this is going to come up a lot during my talk on Jupiter. And the Great Red Spot, even though it's the most famous feature of Jupiter, it has actually been shrinking since we've been aware of it. So for the past like 300 years or so, it's not known whether or not it will go away completely or if this is just normal and it shrinks and then grows, and we don't know. Jupiter, despite being the biggest, has only the 2nd most moons in the solar system. Now, before you go feeling bad for it, it's got 79 of the things. So 79 moons for Jupiter. The 4 biggest ones are called the Galilean moons. Hopefully that name sounds familiar to you. And it should, because Galilean refers to Galileo. So he is credited with the discovery of the moons. So they are named after him. And we talked previously in the year about how even though they're credited to Galileo, another guy, Simon Marius, claimed the discovery as well. And we actually call the moons by the names he gave them, as opposed to the names that Galileo wanted to give them. And those names are Ganymede, Europa, Callisto, and Io. So that's an I, not a lowercase l. And Ganymede is the largest moon in the entire solar system. And we'll talk about very briefly about each of those moons because they are so significant. So Ganymede. Ganymede is named for Zeus's cupbearer. So it's named for a young child who would carry Zeus's cup around. And he was maybe Zeus's lover as well. You'll see with a lot of these moons that there is these characters that they're named after. There is the strong implication that maybe Zeus either was their lover or had raped them at some point. Zeus is not often a good guy. Something I reference in class a lot is Zeus does one of two things to people. He usually kills them or rapes them. Doesn't do a whole lot else. So Ganymede is the largest moon in the solar system. It is larger than Mercury, but it is less massive. So Ganymede is larger physically, like it is a bigger sphere than Mercury is, but it's got less mass. Remember, Mercury has that really big core. It is the only moon with a naturally generated magnetic field. And we think this might be caused by a massive underground ocean. So we think it might be because this moon has so much salt water that it's actually producing electric currents in there and it's got a magnetic field. It might have more water than Earth. So this is a very interesting thing to scientists. And it's got a decent amount of ice. You can see it in the picture here. It's got a decent amount of iron, we believe, and it's a decent, slight amount of oxygen in its atmosphere. So Ganymede's got a lot going on, more than Mercury. There is a picture right here, this shadow, that's Ganymede going across Jupiter. You can see it right over the great red spot. Callisto. So Callisto is once again another of Zeus's lovers, or perhaps one of his victims. You never know with Zeus in Greek mythology. It is the second largest of the Galilean moons, and it's covered in craters. Look at this picture. All those bright spots are craters. And one of the reasons they're bright is probably because they're exposing the ice that's underneath. So you're seeing it's brighter because it's ice. And it's largely composed of rock and ice. And we think this one also might have a lot of salt water underneath its crust. So here is a diagram of what might be under Callisto's surface here. So you can see ice, salt water, ice, rock and ice, rock and ice. Io is different from the other Galilean moons because Io is covered in volcanoes. It is the most volcanically active body in the solar system. Unlike Venus, where it was covered in volcanoes, but they don't seem to be doing anything, Io's volcanoes are doing stuff all the time. So much so that Io is now yellow. And it's yellow because of all the sulfur released from this volcanic activity. And these volcanoes are actually caused by Jupiter. So Io is close enough to Jupiter to where Jupiter's kind of pulling on it. And that pull is actually causing the interior of Io to have this friction that causes it to heat up. And when you heat things up, they expand. And so you end up with all that volcanic activity on the surface. That's an animation of a volcanic eruption that we actually caught. So this is Io. There is a volcano erupting on Io. So you can see it's absolutely huge. Look at that compared to the rest of the moon. Europa, another one of Zeus's lovers / victims. This one is considered the best chance to find life outside of the Earth. It is composed of rock and ice. We are pretty sure there is a large saltwater ocean. We think that it's going to be warm enough underground due to the heat that it is reflected from Jupiter onto it. So this is considered a very appealing target for exploration. Here is its surface. You can see all the ice, the lines that are like tracked in its surface. It's got a very interesting, very strange looking surface here. This is NASA's proposed Europa Clipper spacecraft. So like I was mentioning, that Europa is considered an incredibly appealing target to scientists because of its immense potential for life. So NASA has a mission scheduled to go out and explore that moon. Hopefully you recognize this. This is Saturn. This picture was taken by the Cassini spacecraft. It's one of the most beautiful pictures of Saturn that I think is out there. Saturn is the sixth planet from the sun. Hopefully you could figure that out. We went from Jupiter being fifth to Saturn being sixth. It has the largest rings that we are aware of. It's the most famous feature of it. It's the second largest planet. So we got Jupiter, then Saturn. And we talked about this before. If you could somehow get a bathtub big enough, and if you put Saturn in it, Saturn would float. Now, clearly, this is not practically possible, but if you could, Saturn would float. Saturn is named for the Greek god Cronus, the god of agriculture. And like Jupiter has the great red spot, Saturn has the great hexagon. It's actually at the North Pole. You can see it right there. That's an actual picture of Saturn and its great hexagon. It seems to be continuous, but it does change colors. And this is a natural occurrence. Scientists have been able to replicate this in laboratories. It is just something that weather patterns are very content to do if they have the right conditions. And I mentioned Jupiter had the second most moons in the solar system at 79. Well, Saturn is the winner with 82 known moons. And its tilt is pretty close to the Earth's tilt, so it would have an Earth-like seasonal pattern, but clearly, since it's much farther from the sun, it would have a much longer year, and therefore longer seasons. Saturn's rings, its most noteworthy feature, so of course I'm going to talk about them briefly. Mostly, they are pure water ice, which is weird. Everyone thinks that they're just rocks. Like, why wouldn't they be? But they wouldn't be very easy to see if they were just rocks out there. The reason that Saturn's rings show up so well is because they're water ice, which reflects light really well. And they were likely formed by stuff that Saturn tore apart near it. And speaking of Saturn tearing things apart near it, there is a vocabulary term known as the Roche limit. So the Roche limit is the distance where a large object would be torn apart by the tidal gravity forces that they'd experience near that object. So anything could have a Roche limit. It's just especially pertinent when it comes to Saturn because we talk about how its rings are formed. So if you're a particularly large object, like this wouldn't really apply to humans since we're so small, but let's say a moon or a large enough asteroid, once it enters the Roche limit, what's going to happen is the gravity on either side of the object is going to be too strong and it's going to tear it apart. Or I should say the difference in gravity on either side of the object will be too great and it will tear the object apart, leaving all the little pieces that eventually make the rings. So since it's in red, maybe you should know what the Roche limit is. Now, a couple of the moons that I want to highlight. So we have the Shepherd moons. So they're called that because they actually are inside of Saturn's rings. You can see an animation of two of them here. And since they're inside of the rings, they actually hold the rings together in their specific alignments. Their gravity keeps the rings where they're supposed to be. So they're shepherding them. Kind of like how a shepherd would keep its flock in place. The shepherd moons keep the rings in place. Saturn's most noteworthy moon is Titan. Titan is the second largest moon in the entire solar system. It is also larger than Mercury. Mercury is kind of a puny planet. Titan has a couple really noteworthy features, though. First, it has the most developed atmosphere of any object besides the Earth, that we're aware of anyway. The Earth has a very well-developed, thick, well-maintained atmosphere, and Titan is the only other object in the solar system that has a well-developed atmosphere that's more than just like carbon dioxide like Venus's is. It's got very nitrogen rich. It's drawn comparisons to the early Earth. So the Earth's primary atmosphere that we briefly talked about, it's similar to that. So the Earth millions and millions of years ago. Not only does it have a well-developed atmosphere, it's also got lakes of liquid methane, which number one sounds crazy. But number two, it is the only object that we're aware of that's got liquid on its surface. We think those other moons have liquid underground. Well, that's fine. This one has liquid on its surface. This is huge. Stable liquid on the surface is something that we've only detected on Earth and Titan. If it was liquid water, we would have been sending tons and tons of things to explore this moon. As it is, we've only sent one thing so far. So here's an image of Titan. So there you can see through its atmosphere a lake of liquid methane. Enceladus, another moon of Saturn's, this one's really small. It's covered in pretty much just ice, but it appears to be geologically active. And the reason I say that is we don't see volcanoes, we see like geysers of water coming out of this planet. Here, you can see, here is Enceladus. These are water geysers being sprayed out from that moon. Here's a close-up, and here's a farther away picture. So this moon appears to be active because it erupts with water, which is interesting. An interesting contrast to Jupiter's moon, Io, which is constantly erupting in volcanoes. The ice giants. So here we have Uranus, the more pale blue one, and here we have Neptune, the darker blue one. So there's less to say about them simply because we don't explore them as much. We haven't sent missions dedicated to those planets. So I have less to say about them. They are called ice giants, and that's because they have a larger concentration of water and other ices like ammonia and things like that than the other planets do. And they just look different. They're blue. And they're blue because of methane, not because of ice. They're not blue because they're extra cold. They're blue because they have methane in their atmospheres. This is a huge thing to know. I am going to ask you why they're blue. And they're both about 4 times larger than the Earth in terms of diameter. And unlike most planets, so their magnetic fields are kind of wonky. So the Earth's magnetic field, we've made comparisons. The Earth is basically just a big bar magnet. So the Earth has north and south just going straight through it, and the North Pole is at the top-ish, and the South Pole is at the bottom. Close enough. Neptune and Uranus, quite different. Their magnetic fields don't line up with their rotation axes at all. And we are not entirely sure why, but it's possible they were hit by something earlier in their histories. Uranus got 27 moons. It's tilted almost completely on its side at 97 degrees. This means that if you were on Uranus, the seasons would be far more extreme and far longer than on the Earth. Neptune, on the other hand, has about half the number of moons. It's got 14, and it has the great dark spot. So Jupiter has the great red spot. Neptune has the great dark spot. So that is this right here. Not nearly as, I guess, impressive as Jupiter's great red spot, but it has disappeared and reappeared. So potentially you could make a comparison to the great red spot and say, oh, it's shrinking. Maybe it will disappear and reappear similar to how the great dark spot does. Neptune has its largest moon, Triton, and I don't have that much to say about it besides the fact that Triton does seem to be getting closer and closer to Neptune, which means it's either going to crash into it or eventually be torn apart when it enters Neptune's Roche limit. And finally, the little guy. This is Pluto. So you may or may not be familiar with pictures of Pluto like this. This came from the New Horizons probe. You can see here, this feature on Pluto's right side is often referred to as the heart of Pluto. So it looks like a heart. You can easily see a half a heart. The rest you kind of have to imagine. But Pluto even has a heart, just wanting us to accept him. Poor guy. Here's a little comic. I'll leave it up here for a second so you can read it. So Pluto is the largest dwarf planet in the solar system. There are other dwarf planets like Ceres in the asteroid belt, but Pluto is the largest that we're aware of. The 3 requirements to be a planet. Number 1, gotta orbit the sun. That's easy enough. Pluto does it. Have to have enough mass to make yourself into a sphere. Pluto does. Third one's trickier. Pluto needs to own its orbit or clear its own neighborhood. And what that means is in your orbital path, you need to be the big boy. You need to be the big gravitational influence that causes the other things around you to move, or like other things need to orbit you if they're there, or you need to have gotten rid of them. This is what Pluto doesn't do. It's mostly composed of rock and ice, and it has a thin atmosphere that actually, when Pluto hits winter time, its atmosphere actually freezes and falls onto its surface. Pluto's orbit actually intersects with Neptune. Sometimes Pluto is closer to the sun. So at one point when Pluto was a planet, Pluto would be the 8th planet and Neptune would be the 9th. Pluto, as you can see in this picture here, orbits on a different plane from all the other planets. This is yet more evidence that Pluto isn't quite like the other planets and shouldn't be grouped up with them. Pluto has this weird orbit compared to everyone else. All the other planets are on the same plane, and they all appear to have been created in the same way, while Pluto is in this different plane, indicating it has a different origin. Pluto also spends most of its time inside the Kuiper belt. So we've talked about this before. It's basically a big band of comets and asteroids, and Pluto is more like them than the inner planets. Pluto is not much like the terrestrial planets or the Jovian planets. Pluto's a lot more like the Kuiper belt objects. And I showed you this image here. You can see Pluto very different from all the rest of his so-called friends. Pluto's moon Charon. So here is Pluto, and here is Pluto's moon. Now, normally, a planet that has a moon is going to just kind of like wobble in place while being orbited. But Pluto, because Charon is so large, Pluto actually makes a small circle itself. They behave almost like a binary system as opposed to a planet-satellite system. This is another big reason why Pluto is not considered a planet. Pluto doesn't even seem to own its own moon. It's almost like they're a binary system. It's the largest moon of Pluto. It's 50% of Pluto's mass. So large that they seem to orbit each other instead of the moon orbiting Pluto. It's kind of a problem when you're trying to prove to everyone else that you're a planet when you can't even completely own your own moon. So that's all I have to say about the gas giants, the ice giants, and Pluto. I'm going to post a quiz tomorrow. Make sure you go over this stuff. Try to finish the quiz up by Friday so that next week you're ready to move on to our next unit. If you have questions, please put them in Google Classroom or email me. I'll make another video if I need to. I will write a post if I need to. Just make sure to ask me whatever you got. Be sure to like and subscribe, and I will see you guys on the next one.